Hello everyone, my name is Felipe Rafael Jose Mendoza, and my partner is Oscar Velázquez, and I want to welcome to you to this new video tutorial about how to make a plotter in Geogebra about any function. So the first thing that we need to do is to search in Google Geogebra and one point well, that origin. Then when we are here, we are going to click in the button that says Comienza a graficar, or in English, um, start graphing. So here we can see some function that will help us. In this part, we have the point when all their functions is going to be, and here's a path that will help us to introduce some function. And here we have the Cartesian plane when our function will be plot. So in this case, we are going to use a quadratic function, a cubic function, I mean, in which we are going to define it as fx is equal um, a ax to the cube plus bx to the square plus cx plus d. So we give it enter, and we have now the function graphed in our Cartesian plane. Now, also we have these options in which we can scroll the value of and change the value of each term. For example, A, uh, B, C, and D. So we can change this as we desire, depending of what we need. And if we get double click to here and click in configuration, we can change the color of this function of this plot and even its style, but we are going to leave it like here by the moment. Now we are going to identify a point in this graph. So we are going to declare it as a is equal to punto, or point in English, of f. And now we have this point that we can even move by the graph manually. And as you can see in this part, the value is changing depending on the position. So if we put in approximately x1, we can see how the value is changing. So as we did with the function, we also can change its properties by changing its color and even its style to any other shape that we want. But we are going to leave it like this. So now we have a point. We are going to make to put a tangent that will be our slope, in which will depend in where this point is. So, well, a tangent, I mean. So we're going to declare that as g to write the word tangente or tangent in English. erase this and write and A and F. And now, as you can see, we now have a line in which is a tangent independent of a point, and this will change if we our point, as you can see, have a we can move it over as we desire. So in this case, we are going to change its color and its design for being more easy to see. Go to the design and change the color to green. Green. So it's important to remark that this will help us a lot, especially at the moment of we want to find the critical points in which in which the derivative of our function will be equal to zero or will be indeterminate. And in these points we only can find a maximum and a minimum point that will be approximately here in this point. Here we can find a maximum point because it's the point in which the 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 function is rise to its maximum level, and its minimum point that will be approximately here, where this function will not low below this point. So even when humans can describe this easily, it's not that easy to define it in a mathematical way. So the way we can do it more precisely is by calculating the slope that is defined as the change of a position y over the position or of position x, for example. And we can make that the Geogebra find calculate this value for us by only declaring is equal to pendiente of g. And as you can see here, it creates a triangle, and also it gives us um, the value of the slope. Here, if we change the position of our point, we can see that in every point it changes. For example, here the slope is equal to 2.1. This means that every single change in x will increase that number. So with this we can define the exact position of our maximum and our minimum point by just going to approximately to calculate the slope for when the slope is zero. We will find our critical point that mainly will be a maximum point or even our maximum point on our inflection point. Then is when there's a is follows the rules of a critical point but without being a maximum or a minimum point. So in this point I can put the plot exactly in zero, but this numbers is very accurate. So we can know that our minimum point is in minus 2.9. in the position minus 0, minus has it, minus no 0.26 and minus 2 something, and this will be our point. And even when in this point, as we increase the slope, our value is in this point, our slopes when it's negative and start being positive, we can say that when our slope is negative, the the function increases, and when it's positive, uh, and when the sign of this the slope is positive, actually the point is getting slower. So that will be the video for today. Thanks for watching and see you next time.